Hello everyone and welcome back to my channel. In this video tutorial I'm going to introduce one of the AT51 simulators, namely EdSim51. This is a simulator that can be used for both educational purposes and also can be used for professional AT51 based embedded system designers. Let's see how we can download the software first. Go to the edsim51.com. This is the home page of the software website. As you can see, there are different tabs here. So you can see some examples. You can see the user guide here for the installation. Come to this link. Since EdSim51 Simulator is written in Java, you need to install first the Java runtime environment in your system. If you don't have it, you can download it from this link. And then you need to only download the EdSim51 Simulator from this link. There is a zip package, and as you can see, there is a one Java file and a folder. Only you need to extract them in your hard disk, and then by click on this one, you can run it. I extracted the zip file in this folder, and now click on this file to run the program. So this is the main window of EdSim51 environment. As you can see, there are different panels for registers and memory content. The editor panel for programming. There is a panel that mentions the pin assignment, and in the bottom you can see some virtual peripheral devices such as 7-segment, LCD, keypad, switches, LEDs, analog to digital converter, and also DC motors and serial receiver and transfer. Let's focus on the left panel first. As you can see, the content of the general purpose registers are written here. Also, some of the special purpose registers such as accumulator, B register, program status word, interrupt priority, interrupt enable, program control, data pointer, high byte and low byte, and stack pointer also written and displayed in this part. All of these registers content can be manually changed. For example, if you want to change the content of this register, you can enter it here. 0x for hexadecimal base numbers, and for example FF. So I initialize register 0 by this number. But the ones that are displayed in gray color cannot be changed. Again, you can see the timer registers here, timer mode, timer control. These are some of the special function registers for the timer 0 and timer 1. The program counter, a register that indicate the address of the next instruction that should be read from the memory and execute by the microcontroller, the value of the ports. And in the bottom of this panel, you can see the content of the data memory. This is the address 0, 1 till 15, address 16 to 31 that are displayed in the hexadecimal. So this is 1011 in the hex till 1F, 202122 till 2F. So again, if you want to initialize the content of the memory manually, you can use this part. This is the address and this is the value. For example, I'm going to put in address 30 hex a value AB. So the address is 0x30, and the value that I'm going to add here is 0xAB or AB hex. As you can see, AB hex is entered in the address 30 hex. Also, when I initialize the R0, you can see that the first address of the RAM location is initialized, because as you know, the first 8 bytes of the RAM belongs to the bank 0 register. So from here till this point, this is R0, R1, R2, R3, R4, R5, R6, and R7 of the register bank 0. From this point till this point is the content of the register bank 1, register bank 2, and this part is register bank 3. By default, we are working with the register bank 0. So when I mention, for example, here, initialize it to 0x12, the corresponding memory location is changed. So R6 register is declared here. But also you can initialize any other locations by indicating the memory address here and its value in the value box. In this part, you can write your code. Let me write some simple instructions. Move accumulator and number 100 in the decimal, and add accumulator with number 50 in decimal, and I'm going to run it. For this purpose, first you should assemble your code. If there isn't any error, you can run it. Click on this one, and as you can see, no errors message is appear. It means that there isn't any problem in our code. This is the address of the first line, and this is the address of the next instruction. So it means that the first instruction takes 2 bytes, and if you want to see the machine code of this instruction, you can come here, click on this button, data memory. Now this part is changed to code memory. This 2 bytes 7464 is the machine code of the first instruction. 2432 is the machine code of the second instruction. As you can see, this is the opcode byte, and 64 is the equivalent of 100 in hexadecimal. Again, this is 50. If you convert it into the hex, it is 32. This is the reason that you can see 32 here. So opcode and the immediate data in 2 bytes. Let me run the program. For running the program, there are 2 options. Run step by step or run the whole program. I'm going to run it step by step. So as you can see, the program counter is 00. When I click on this one, the first instruction is executed. Now the program counter content is 0002, the next address, and the accumulator should be changed. Let's check it. Yes, here as you can see, the content of accumulator become 100 or 64 in the hexadecimal. Now if I add it with 50, again press step, the content of the accumulator become 96 in the hexadecimal, which is equivalent to 150. The program counter value changed to 0004, the address of the next instruction, which is empty. And also, if you want to see the content of the carry flag and other flags that are affected by this add instruction, there are in the program status word register. But if you want to see them by one, you can type it here, the PSW, then the content of the specific register that you mentioned will be displayed in these 8 bits. Also, if you want to see the name, you can press this I or information button. Now, if I keep the mouse on a bit, the name of that bit will be displayed. This is the carry flag. This is the auxiliary carry, F0 flag, register select 1, register select 0, overflow flag, and parity flag. So if you want to know the value of each of them, you can find it in this way. As you can see, this addition does not have a carry, and the carry flag is 0. The parity is 0 because if you check the content of the accumulator, let me write it here. Check the content of the accumulator. Count how many ones we have in the accumulator now. 1, 2, 3, 4. So the number of ones in the accumulator is even, so the parity will be 0. So parity will be set to 1 in order to make the number of ones in the accumulator become even. Since I have already even numbers of 1, therefore the parity is 0. Back to the program status 4. The reason that the parity is 0. If you want to modify your code, you should reset it, and then this editor become again white, and you can change your code. This time, instead of add, I'm going to perform the logical AND. Assemble and run the whole program this time. So as you can see, the program counting continuously because there isn't any end in the final statement. So it is continuously executing the memory, and the memory which is now, if you check it here, the memory content is 0. 0 is a opcode of no operation in the 8051. So all of these no operation are now executing, but I don't want to execute them, so I'm pausing.